This one says write the radical function that results from applying each of the transformations. So this one we have a vertical stretch by a factor of 3. So remember that the form for a radical is y equals a square root bx minus c plus d. So same letters as before, right? If it's with the x, it's under the radical. If it's outside the x, it's with the vertical. So vertical stretch by a factor of 3. So we get a 3 in front. Reflection in the x-axis. So we get a negative 3. Translation 4 units right. Say horizontal translation 4 units right. So we're going to get x minus 4, and then 2 down minus 2. That's the vertical translation, right? We agree? Okay. BCD. So we have a horizontal stretch factor. We're going from words to equation. Remember? Words mapping in a heart to equation. It flips, right? X's be crazy. So, horizontal stretch by a quarter, we're going to get a 4 under our radical. Reflection in the x-axis, we're going to get a negative 4. The translation 3 units up and 5 units left. Make sure you have a bracket, x plus 5, because we have to make sure we have a 1 in front of our x, remember? So even if they have the option where the bracket is distributed, you still start with it in a bracket and then distribute your number through. Okay. Vertical stretch by a factor of 2 about the x-axis. So we're going to get a 2. Horizontal stretch by a factor of 3 about the y-axis. So we're going to get a 3rd. Vertical translation 1 up. Horizontal translation 4 units left. And then D, we have a vertical stretch by a factor of 3. Horizontal stretch by a factor of 1/2, so it goes in as a 2. Reflection in the x-axis, so that's with the y value. And y-axis, so that's with the x value. And a horizontal translation, 6 units left. Yeah? Okay, let me go to the next page. Okay. So these ones we're trying to map a function. Now remember, let's talk about the parent function. The parent function, y equals root x, is at 0, 0, 1, 1, 4, 2, and it looks like this, up and to the right, correct? Up and right. So that's how we can tell if there's a reflection. If it's not up and to the right, it's reflected. Okay? The other thing we have to talk about is what's the only thing that can move this off of 0, 0? Can stretches move it? Stretches multiply, correct? If I multiply by 0, does it change it? No. So a stretch doesn't move it. A reflection doesn't move it. The only thing that moves this one's special. The only thing that moves the starting point, because it's 0, 0, is horizontal and vertical translations. So actually, wherever that starting point is the horizontal and vertical translation, only because it starts at 0, 0. The other special graph where that works is a quadratic, because a quadratic is an x squared graph, and it starts at 0, 0. So if it doesn't start at 0, 0, you immediately have the horizontal and vertical translations. Anything that starts anywhere else, you can't do that. You have to do it a different way. Okay. So let's talk about this one. It's obviously up and to the right. Oh, crap. It's down and to the left. So it's actually reflected in both. Do we agree? Because up, if it was up and it's now down, it reflects in the what? Up and it's now down, it reflects in the x-axis, correct? If it's right, but it's now left, it reflects in the y-axis. We agree? So this one is reflecting in both. So it's this one. Yeah? So this one is little d. Okay, this one is up and to the right. So what reflection should it have? Trick question. None. This is the only one that doesn't. Do you see that the difference between A, B, C, and D here is just the reflections? Everything else is the same, right? Okay, what about this one? Up and to the right. Oh no, it's not up and to the right, it's down and to the right. So if it's down, it was up. What's it reflecting in? The x-axis or the y? The x, because if it was here and it's now down, it's in the x-axis. What does that affect when you reflect in the x-axis? What does that affect on the equation? The a, the y's. So, it's this one. And then we don't just go, okay, the last one's the other one. No, you double check to make sure it is. So normally I'm up and to the right. Now I'm still up, but I'm to the left. What am I reflecting in? The y-axis. What does that affect? The x values. So, only the x values, it's this one. So most people type it into their calculator right away and try and compare. You don't need to, right? Just use your reflections. All right, next page. Okay, this is where it gets a little more complex. We need to figure out our A or B or C or D. Now the catch here is we're either going to have an A or a B. We're not going to have both. Okay? Reminding ourselves the original graph is 0, 0, 1, 1, 4, 2, 9, 3. That's my original. We agree? 0, 0, backpack. Doesn't even get to go on the left. And the earbud. You lost that too. All the things. Ivan basically has nothing left but his soul. His soul is still there. Winning. All right. So does this have any reflections? It's up and to the right. This is up and to the right. Does it have any reflections? No. No reflections. Okay. I told you because it starts on 0, 0, the only thing that can move it is translation. Do you agree? So this would have 1, 2, 3, 4 to the, which way did we go? Right, and 1 up. So we know we moved 4 right. We know we moved 1 up. We know there are no reflections. Now we have to talk about stretches. So this is the key thing to remember. Everyone paying attention so I don't lose you? Okay. The original is a 1 by 1 box. Do you see that? So we're either going to do a 1 by something box, or we're either going to go 1 horizontally or 1 vertically, okay, to get to the next point. This one goes 1 what? Horizontally to get to that point, correct? So there's no horizontal stretch here. Do you see that? There is, but it's not going to be easy to find. So this is 1 to 1, and this is 1 to what? 3. This is a 1 by 1 box. This is a 1 by 3 box, correct? So what type of stretch is that? Is it vertical or horizontal? Vertical. Okay. So we know we have a vertical stretch by 3. If I had to handwrite this out, could I do any of this in short form like I'm doing? No. What's it asking for? Just the equation, correct? So that's to help me out. Okay. So I'm always going to get 2 equations. I'm going to get a horizontal stretch equation or a vertical. But I do whatever one's easier first. So this one, the vertical stretch is easier because the horizontals are both wide. Okay? So let's try it out. Y equals the vertical stretch by 3, square root, no negatives, no reflections, 4 to the right, so x minus 4 and 1 up. So like I said, either a vertical stretch or a horizontal. Now this is the good thing. Once I have one of them, I can get the other one very easily. So this is one option of equation, or, and do you just send it and hope for the best that it's right, or can you actually type this in and make your window be the same as that and see if they match? Right? That would be better than just sending it and hoping it's right. Okay. Now, what we can do is we can actually move this 3 inside here because it's a square root, which we were taught in grade 10. Everything's grade 10. We loop back to grade 10 very often. So we get y equals square root something x minus 4 plus 1. How do I move the 3 from outside the radical to inside the radical? What do I do to it? To take it out, what do you do? Square root it. So to put it back in, what do you do? Square it. So what's 3 squared? 9. So what's my horizontal stretch actually? 9? 1/9. Because if I go up 1 here, I only go over 1/9. I just can't tell if that's 1/9. So that would not be the most productive way to do it. So you're either going to have a vertical stretch or a horizontal, not both. Okay? Let's look at this one. It's up and to the right still. I always draw my original on to help me. 0, 0, 1, 1, 4, 2, 9, 3. So this is up and to the right, this is up and to the right, so I know there are no reflections. We agree? Let's talk about stretches. Okay, this is a 1 by 1. This is a 1 by 2. So which one isn't 1? The vertical or the horizontal? Vertical. So that's a 1. So we have a vertical stretch by a factor of 2. I'm just doing short form because they aren't asking me for the words, right? If they were asking for the words, I wouldn't go for short form. And because this starts at 0, 0, the horizontal and vertical translations are really easy to find. We count them. So this is going to be 1, 2 down, and 1, 2, 3 what? 2 down and 3 what? Left. Because we start at 0, 0. So some people tell me 3 right, 1 up. No, we start here. How did we move? So let's make an equation. Y equals 2 square root x plus 3 minus 2. Or, how do I make the other one? With a horizontal stretch. Bring the 2 inside. How do I bring the 2 under the radical symbol? How do I bring the 2 under the radical symbol? Square it. So I'm going to get y equals the square root of 4 x plus 3 minus 2. Now what horizontal, so it's a vertical stretch of 2. What's the horizontal stretch then? 1, 4. You guys try C and D. So normally it's up and to the right. We draw it. Normally it's up and to the right, but it's actually down and to the left. So which way did it reflect? X-axis or Y-axis? X. Remember short forming because they didn't ask me for the actual words, right? Okay, let's talk about stretches. So this one is 1, 1. This one is 1 horizontally and 4 vertically. So it's a vertical stretch by 4. Okay. And then it starts at 0, 0, but it's now 1, 2, 3 up. 1, 2 right. So we have y equals 4, negative 4, square root, x minus 2 plus 3. Or, I can't bring the negative sign in, that still stays out, right? But what does it come in under the radical as for the number? 16. X minus 2 plus 3. Yeah? Okay, and this one is down and to the right as well. normally here, but it's down and to the right. So we know that there's a reflection in the x-axis. Stretching. 1, 1. This one is 1, 2. So it's a vertical stretch by 2. And then I move 1, 2, 3 left. And 1, 2, 3, 4 down. So we have y equals -2 square root x plus 3 minus 4. You bring the 2 inside and it becomes a what? 4. Try number 5. We have to describe the transformations and we're going to write them thoroughly. So we have a vertical stretch because we're going from our equation to words. Y's always stay the same, but x is too crazy. Vertical stretch by a factor of 1/2 about the x-axis. And a horizontal stretch by a factor of 1/6. Ellipse about the y-axis. Then it says write a function equivalent to y equals 1/2 6x, where in the form a to the x. So they want to move everything out. So how do I move that 6 out? What do I have to do with the 6? Square root it. So I'm going to get y equals 1/2 square root 6 root x. So it's going to be y equals square root 6 over 2 root x. So when you take it out, you take the square root of it. If it's not a nice number, it stays square root 6, right?
But like the first one that you wrote, you write like 1 over 2 root x. Or 1 over 2 root 6 root x. Or you have to like simplify it. 6 over 2.
You would simplify it, but it wouldn't be the end of the world if it's like that. But what did you write for vertical stretch? 1/2 root 6?
I wrote what you have.
Yeah, but when you wrote words, describe the transformation. You just didn't keep reading? Okay. Vertical stretch. You stopped at the decimal, at the period, and didn't keep reading? Vertical stretch by a factor of root 6 over 2 about the x-axis. And then write the function equivalent to that. So we're going to put it inside now. How do I bring the 1/2 inside? Square root it to bring it out. So what do I do to bring it in? Square it. What's 1/2 squared? 1/4. And I wrote 6. Good job. 1/4 times 6 x, which gives me 6 over 4. If you're doing fractions and you don't remember how to multiply them, put the other number over 1, because then it stops people from trying to distribute it to both numbers. So you get 6 over 4, which reduces to 3 over 2x, and your horizontal stretch always flips. So we get a horizontal stretch by a factor of 2/3 about the y-axis. Yeah? Mapping xy becomes x through y. All right. And then your domain and range are accordingly to what's left over. So this just goes through and it gives you where things will be and it gives you a little summary. So what we're going to do is we're going to draw the graph of 4x minus 3 from a table of values. So we have y equals 4x minus 3. And then we go second trace value, 0, which is negative 3. And then we go 0.75 and we get 0. 0.8 and we get 0.2. 1 and we get 1. 2 we get 5. 3 when we fill it in, we're going to get 9. And then 5 we get 17. All right. Then we do the square root of 4x minus 3. So what are we doing? We're taking the answer from 4x minus 3 and we're just doing what to it? Square rooting it, correct? So what's the square root of negative 3? Does not exist. You can't take the square root of a negative number, correct? So the very first y that's going to exist is when y equals 0. Because we can take square root of zeros and we can take square roots of positive numbers. So the square root of 0 equals 0. Then we take the square root of 0.2. And we get 0.45. Square root of 1 is 1. Square root of 5 is 2 point something. 2.2. Square root of 9 is 3. Square root of 17 is 4 point something. Okay, so we'll sketch the original in blue. So I'm going to go 0 and negative 3, 0.75 and 0, 0.8 and 0.2, 1 and 1, 2 and 5, 3 and 9, and then 5 and 4.1. Nope, 5 and 17. So if we connect these, we get the line y equals 4x minus 3. This whole lesson, we're rooting the entire function. Like, you know, last one there was the vertical stretch was outside, the vertical translation was outside, we were just moving the y equals root x graph. We're not moving the y equals root x graph. We're taking a function and we're square rooting the entire function. So every y of the function gets rooted and the x's stay the same, right? That's why we get xy becomes x root y. So the x's are staying the same and the y's are being rooted. So at 0.75 we have 0. This bottom part of the blue graph doesn't exist on the radical graph. And then 0.2 becomes 0.45, or sorry, 0.8 becomes 0.45. So it actually goes up. The only number that gets bigger when you square root are numbers that fall between 0 and 1, right? When you square root a decimal between 0 and 1, it actually gets bigger. Everything 1 and higher gets smaller, like square root of 9 is 3, square root of 4 is 2, right? But when you square root anything between 0 and 1, it gets higher. So look, it came up here. This one stayed the same, and so did this one. So this is invariant, and this was invariant. Why are when y is 0 and y is 1, why did they stay the same? Why did they stay the same? Square root of 0 is what? 0. Square root of 1 is what? 1. So when I take the square root of 0, these don't change. The square root of 1, these don't change. So the mapping, when we go from a plain function to the square root of the function, The invariant points are always when y equals what? They exist when y equals 0 and 1. Square root of 0 and square root of 1 stay the same. All right. Then we have 5 and 2.2. And then we have, that's not 5 and 2.2. It's 2 and 2.2. I don't even know what it is. 2 and 2.2. 3 and 3. And then 5 and 4.1. Okay? Really? Really? Okay. So the domain of the original was XER, correct? It's the line. So the domain of this one is X such that X and L are the reals. What's the domain of this one? X such that what? What X did it start on? What X did it start on? We have a table of values. Here was the Y. What X did it start on? Family domain. 0.75. So the x-intercepts of the original graph are so important because that's where your graph is going to start. That's when y equals 0. So it's going to be x is greater than or equal to 0.75. X is down to the real. Then we're going to flip over. So basically everything above the y or above the x-axis will get reduced, except for between 0 and 1. And everything below the y-axis goes away, because you can't take the square root of a negative. All right. I want you guys to draw the original. And I need at least 6 points on the original. Which are the important ones for sure? When y equals 0 and y equals 1. So find those out. And if you want to use your calculator, you can. You would put this in to y1, and then into y2 you could put 0, find out where they intersect. Then once you do that, in y2 you could put 1, find out where they intersect, and get those coordinates. Go. So when I graph the original, I need the minimum first. Left bound, right bound, enter. I get a minimum at, so this is my original, at negative 0.5, comma, negative 5.25. So that's my minimum. 0, negative 0.5, and negative 5.25. So it's here. Okay. Then I can pull any other values I want off the table. So off the table I get 0 and negative 5. And then I get negative 1 and negative 5. And then I get negative 2 and negative 3. And 1 and negative 3. And then I get negative 3, 1. And I get 2, 1. And then I get negative 4, 7. 3, 7. Now what am I missing? The x-intercepts. So if I put y2 equals 0 and I find out where they intersect, second trace 5, enter, 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 I get negative 2.79 and 0. Remembering my x-intercepts are very important. That's where my new graph is going to start, the radical graph. Second trace 5 onto the other one. Enter, enter, enter. I get 1.79. All right. So then I just go a little past the dot I have. If I don't have more dots, I can't just go like this. You go a little past your dot because you've lost accuracy after that. I get the craziest graphs drawn. You can go a little past and put an arrow. Okay. The mapping of my new coordinates are going to be x stays the same, y gets rooted, right? Remember, mapping is x, y becomes x root y because I'm rooting all of my y, correct? So this one is going to become 1.79 and the square root of 0, which is 0. Stays the same. This one is negative 2.79 and 0. It's going to become negative 2.79 and 0. Square root of 0 is the same, so that stays the same. And then what other one stays the same? Oh, these two. Negative 3 comma square root of 1 is 1. And then 2 and 1, those don't change, so they're invariant. 0.5 goes a little higher. So these both go a little higher. What happens to all these negative ones? So like this one, it becomes negative 0.5 comma negative or square root of negative 5.25. What is that coordinate? It doesn't exist. Can't take the square root of a negative number, right? And then this one's going to become 0 and the square root of negative 5. Also not a thing. This one's going to be negative 1 and the square root of negative 5. Also not a thing. This one is the negative 2 square root negative 3. Nope. 1 square root negative 3. Nope. So those are all gone. So the purple, like that little purple below the x-axis, doesn't exist on the blue graph, correct? And we have these two, negative 4, and then root 7, correct? Because these would be root 1, but root 1 is just 1. These would be root 0, but root 0 is just 0. Yes? Square root of 7, it's between 2 and 3. 2.6. So I'm now going to get negative 4 and 2.6. And then this one's going to be the same, 3 square root 7. So 3 and 2.6. And so some people do this. What is that? Is there a coordinate between here and here? No. So is that accurate at all? When you do that? It actually causes you to lose marks. You can go a little past, but that's it. And if you want more past, then you have to draw more. Okay, you can't just like put, I see people do this, they're like, I'm like, where the heck did the rest of those lines come from, crazy people? What the heck? What the heck? What the heck? Okay. All right. Okay. So the graph shows that the function extends to the left and right infinitely. So the domain of the function is the purple function. Oops, we'll talk about this one. The purple function's domain is what? This one has a domain of x such that x and down to the reals, correct? It's quadratic. Correctamundo. What is the domain of this one? X such that this is negative 2.79, I believe. So it's going to be x is less than or equal to negative 2.79, or x is greater than or equal to 1.79 XER. In interval notation, it's from negative infinity to negative 2.79 closed bracket or square bracket because it's equal to, or is a union symbol, 1.79 to infinity. You can't equal infinity, infinity goes around. The other thing to note is this is invariant. Very thick red marker. And these two are invariant. Because it happens when y equals what? 0. 0 and
1.
1 because y equals square root of 0 is 0. Y squared 1 is 1.